Hello everyone, welcome back to our YouTube channel Agri. This is our lecture series for IBPS AFO mains exam and also useful for other agriculture exam as well. Today we'll be dealing with one more important topic of the agriculture engineering, that is energy resources. Before that, let me introduce myself. I am your mentor Kumar. I have completed my UG from US Raichur and currently pursuing my masters in plant pathology from UHS Shumaga. As I told, today we'll be dealing with the topic called energy sources. Let us start the session by knowing the factual data of the energy and what is the condition, whether the India is importing the energy or whether it is exporting it, and what actually we are doing for the production of energy, and how much shortages is there, and what are the sources on which we are dependent. First, talking about the factual data that depicts on which source we are relying more. See, for 70% of the energy generation is being dependent on the fossil fuels. That is, using the fossil fuels, we are generating 70% of the energy, and using coal, it is 40%. Using crude oil, 24 percentage we are generating, and 6% the natural gas is being used. This is the data that you should keep in mind. Okay. Next, India's dependence on energy import is expected to exceed more than 53% of the total energy consumption, because the activities that require the electricity is increasing day by day. Hence, this is the situation of this India. Okay. And next, talking about the India's coal imports for electricity is increased by 18%. Okay, it has been increased, and even now we are falling with the coal shortages sometime. Why? Because the need of electricity generation. Next, it is mainly because of the economic expansion. The Because of the economic expansion, this electricity import has been become necessary. And now, last, the thing you should remember, India also envisages to increase its contribution to the nuclear power to overall electricity generation capacity from 4.2 to 9% within 25 years. See, earlier it was only 4.2% in the nuclear power generation. Now we have reached to 9% within 25 years. This is very remarkable achievement of the India. Okay. Okay, now let's see what actually the energy is. When I say energy, it is nothing but an ability to do work or a capacity to do work. Energy is measured in terms of calories, joule, watt, horsepower, watt, and volt. Okay, and basically we classify the energy into two terms, that is potential energy and the kinetic energy. Potential energy is nothing but, simply in simple terms, it is stored energy, and kinetic energy is nothing but it's an energy which is possessed by the virtue of being in motion. If you take the example of potential energy, it is the stored water in the dam, and for kinetic energy, simple example, it may be a windmill or bullet from the gun, etc. Okay. Now, please look into this particular graph. The data. This is very important. In the worldwide, the non-renewable energy consumption is around 82%. Means that much 82% resources being used as a energy source, and only 18% of renewable energy sources are being used as a energy source. Here, majority is being occupied by the oil, 33%, natural gas, 21%, coal, 22%, and in the renewable section, biomass 11%, nuclear power, sorry, hydrothermal power 7%. These are both together is adding 11%. This will be the 11%, and this plus 7% altogether adding for 18%. Sorry, make a correction. 11% is from the biomass, and left 7% is from the wind energy, solar energy, and the geothermal energy. Altogether 18% from the renewable sector and 82% from the non-renewable sector. And next, looking into the classification of the energy. So this is very important. In exam, you will be getting normally questions, which of the following is a renewable source, which of the following is a non-renewable source. Okay, you should be clear between the which are the renewable sources and which are the non-renewable sources. Now, earlier in NABARD exam, one question was there, right? Which of the following is a renewable source? An answer was biomass. Biomass is not only a single renewable source, many were there, but among the given option, it was correct. So you should make a note of it. See, under the non-renewable sources, we majorly get these things, that is fossil fuels, coal, oil, natural gas, heat, nuclear power. These will be under the non-renewable resources. And under the renewable sources, it will be solar power, wind power, geothermal energy, biomass, tidal power, wave power, etc. Again, under the solar power, we have two things, that is for so using the uh, solar photovoltaic cells and the thermal plates, that is solar thermal, since using it maybe for an solar cooker or anything, etc. Okay. Next, under the biomass, we will be having these things, these processes that will be using to generate the energy. It may be by the combustion, gasification, biogas, biodiesel, and bioethanol. We'll learn these things in upcoming slides. Okay, don't need to worry. And the most important thing is to remember natural gas is a non-renewable. Okay, it is a non-renewable source. Okay, it has the maximum content of a methane. Remaining will be constituting the least how much it is left. If 90% is a methane, then in the 10% all these gases will be there. If it is a 50% and remaining 50% will be distributed for these gases. Okay. Next, the chemical composition of the biogas. This is also very important from the exam point of view. Please make a note. Methane is around 50 to 70%, carbon dioxide around 25% to 50%, and other constitutes along less than 5%. Okay, make a note of these things also. And some traces of the H2S and ammonia also found along with these methane gases. Next, here, two important factors you should remember: which organisms are involved in the acidogenesis and which are in the symbiotic relationship between the hydrogen producers. Here, Clostridia and okay, here the Clostridia, it is involved in acidogenesis. Means mainly during the biogas production, there are some three stages in general. First, the complex organic matter, that is a cow dung, whatever we will be submitting. First, it undergoes hydrolysis. Okay, then that complex organic compound will be converted into the simpler organic compounds, that is sugar, amino acid, fatty acid. And now this will be acted by the acidogenesis process. Here comes our acidobacterus, that is Clostridia. This it will act upon these hydrolyzed products that gives volatile fatty acids, and now this will be acted by the acetogenesis, that is by acetogens. Okay, these will act upon these particular products of acidogenesis and gives us the acetic acid, carbonic acid, and propionic acid respectively. Now, these products of acetogenesis will be acted by our methanogens. Finally, they gives us the methane and carbon dioxide. So this is how you should remember acetogenesis, which is the bacteria, it is a Clostridia, and for the acetogenesis, acetogens will be helping, and for the methanogenesis, methanogens will be helping mainly the methanosata and methanosarcina. Should remember them. Okay. I hope now you are clear with the composition of the biogas and what are the steps involved in the biogas production, that is hydrolysis, acidogenesis, finally the methogenesis. And next, coming to the various forms of energy, chemical energy. First one, see when I say chemical energy, it is the energy that is stored in between the bonds. Take example CH4 as a methane. Okay, see in the center. And now the energy that is present in between these bonds is broken. When this particular molecule is broken, the energy is liberated. That is the one we are using as a source of energy. Okay, the energy that is stored between the bonds of atoms and molecules. For that, we can take example of biomass, petroleum, and the natural gas. Okay. Next, nuclear energy, energy that is stored in the nucleus. Obviously, you know the nuclear chain reaction, right? And the neutron will be bombarded. The nucleus of any, take example of uranium, the nucleus will be bombarded with a neutron, and this goes on splitting. This is how the lot of energy liberated during this process that is being trapped for the energy production. Next, stored mechanical energy. It is the example you can learn. I think it is stretcher rubber bands and the compressed rings. People may be knowing this compressed ring. When this is released, it goes this means energy is retained back here. And rubber band, when you stretch and leave, it compresses again into origin. That is the energy which is stored in that rubber bands in the compressing, it will be expressed. Here, majorly energy is stored in the objects. Okay. Next, gravitational energy. It is the energy of place or position. You can take the example of hydropower dam. Okay. When water earlier it is having storing its own energy, hydropower dam, but when the water is released from the dam, it will be spinning the turbines and finally it is converted into the rotational energy. Next, radiant energy. Radiant energy is nothing but an electromagnetic energy, and that will be traveling in the transverse waveform. And the best example is our solar energy is an example for the radiant energy. You should keep in this mind. Most of the time we fail to remember this solar radiation is a radiant energy, and along with that our gamma rays, X-ray rays, all will be the examples of this particular radiant energy. Next, talking about the thermal energy is also the energy that is present internally, that is internally in the substances. We can take the example of our geothermal energy, that is the energy which is present inside the earth surface. See, when I say thermal energy, it may not be always the geothermal energy alone. Even it may be the energy that is present inside the atoms or any substance. Okay, I think you are clear with all these energies. Next, moving on to the electrical energy, the energy that is due to the movement of electrons. Electricity, we will be remembering. You should remember along with that this particular thing. Okay, the electrons is also coming under this particular thing, lighting. Okay, lighting will also be coming under the electrical energy. Next, motion. The movement of subjects as a substance from one place to another place in a motion. Okay. Example will be the wind and hydropower are the example of motion, because when air is in motion, wind power is working, and when water is in the motion, okay, when water is in motion, that particular thing, the turbines are rotating, right? This is how the basically turbines is same. Wind turbine rotating here in the surface, like in atmosphere, whereas water in the depths, the turbines will be rotating. Overall, the energy will be produced. And in the sound, is a movement of energy through substances in longitudinal waves. And light energy, it is a type of wave motion where light is helping to see the things, right? It is making us to see visible. Geothermal energy which is stored, one which is present in the earth surface, that is being utilized. Next, talking about the applications of solar energy, it is have wide applications. Few things I have listed here. Basically, talking about the solar cooker, solar water heater, greenhouse heating, solar fencing, solar alarm. These are the major applications in agriculture. And talking about the applications of wind energy in agriculture, we are using the windmill energy for pumping of water, for electricity generation, as well as grinding. And very important to note here, we can operate the windmills only when the wind speed is higher than 15 km per hour is necessary. Okay. Next, you should make a note of this also. And tidal energy, using the tidal energy, that is the tides that are created due to high tide and low tide, the energy, what the difference will be getting between the high tide and low tide, will be used to rotate the turbines. Basically, the tidal turbines, tidal barrages, tidal lagoons. We will be seeing the pictures so that you can remember very well. Okay. This is the tidal turbines. It is installed inside the water sometime, okay, near the shore, to certain depths, or it may be uh, located in the tidal barrages. Tidal barrages is like a dam like structure, it is similar. In between here, these turbines will be installed, so when tides come and hit for the turbines, they will rotate and they will generate the electricity. And this is the tidal lagoons. It is a small scale investment compared to the this particular tidal barrages. Similar way it will be there, but the cost of construction will be less and impact also will be less. Next, now we have studied the tidal barrages, right? The same way, here the we'll be learning that what actually we are utilizing generation of electricity. In tidal stream generator, what happens? We are you making use of the kinetic energy of the moving water. It is important to note, okay, to power the turbines, similar to wind turbines. Next, in tidal barrages, we are making use of potential energy difference to run the turbines. Okay, here potential energy is being used, here kinetic energy. We should be clear. Tidal barrages and the tidal stream generators. Next, classification of the energy on the basis of source. Here, we'll be classifying like direct source and indirect source. When I say direct source, it is the energy will be released directly. Indirect source means energy will be released, but not directly. It is indirectly by some kind of conversion process is involved. Here, for direct source of energy, example is our human labors, because we are doing directly, right? After eating directly, we are performing tasks, right? And electric power units, they will be the example of direct energy source. And indirect energy, seeds, manures, chemicals, fertilizers, machinery. See, once you sow the seed, directly they do not germinate. They will take the help of soil and water they absorb, and later they germinate. Even chemicals, they do not release their energy directly. When they come in contact with the water, then their action starts. This is how the They release energy by some kind of conversion process. Next, classification of energy on the basis of comparative economic value. This is based on economic value. We should note on it. Okay. A non-commercial energy and the commercial energy. Usually, the non-commercial energy will be available cheaply. This should be noted. And the source will be our fuel wood, agro waste, and animal dung. Whereas for the commercial, it will be our petroleum. Okay, we can note of it. Next, advantages and disadvantages of different energy sources I have listed. Please pause the video and make a note date, because there is nothing to explain much, I think, over here. But one conclusion what I want to give for this slide is the advantages of renewable sources may be more and they're good for the environment, but generating the energy from those sources require large amount of raw material. Generally, when we are generating energy from the renewable resources, whereas from the non-renewable sources, even if you have small amount of the raw material, you can generate more energy, but they are harmful for the nature. So it is left to us how much we are interested in protecting the nature. Next, thermodynamics. This is very important to study in this source. Okay. Uh, Thermodynamics is nothing but the study of energy and its transformation. Everyone of know it. In our agriculture, in living material, we will be learning only two laws. First law says that energy cannot be destroyed or not be created. Right? It can change from one form to another form. Example is simple. What happens is the sun energy is present. Right? Now, this energy which was in the form of light energy or heat, now this is converted into chemical energy. Okay, by means of photosynthesis. Okay, here the form has been changed. This is light energy is being converted into a chemical energy. That's it. Form has been changed. This is what the first law says. Energy cannot be created nor be destroyed, but it can change its form from one form to another. And second law says when energy is converted from one form to another form, some of it is decreated. Means when light is being converted into chemical energy, some losses will occur. Obviously, you should agree. Another example which I mentioned is ice cube. See, to maintain the water in the ice cube structure, it needs some kind of special energy. But when this ice cube melts into water, the energy will be lost. Some kind of energy that is holding its structure. This is the second law of thermodynamics. Be clear with those with these two law of thermodynamics. Okay. Next, talking about the geothermal energy, that is the energy which is stored in the earth surface, that is underground. What we do here usually is hot rocks will be there inside the surface. Cold water will be pumped down, and because of the hot rocks, that cold water will become heated, and that we will be lifting, and the steam will be used for generating the electricity by using the steam. First, we will be rotating the turbines, and those turbines in turn will generate the electricity. These are the steps. What I explained, it is written here. Okay. Next, advantages and disadvantages. See, obviously it is good for environment, and extraction of the geothermal energy causes the greenhouse emissions. This is the drawback. And geothermal energy is a reliable source of renewable energy. Means you can depend upon this. Okay, but there is a possibility of depletion also. Okay, and geothermal high efficiency is more, but cost investment of these plants is more, and there is no little geothermal system maintenance needed. Okay, though we know there is no need of a maintenance for this geothermal plants, yet it is very hard to implement it. Okay, there is an unlimited supply of geothermal energy, we should agree, but at the same time, geothermal reserves cannot easily be found because it is very difficult to discover these reservoirs first of all. Next, talking about the biofuels, majorly we'll be using in ethanol and the biodiesel. Okay, and some of the agriculture products that were specifically grown for production of biofuels have been listed here. So you should make a note. See, in India, we are growing jatropha for biodiesel production. In Asia continent, palm oil and miscanthus. In China, it is a cassava and sorghum. In Europe, it is a sugar beet and wheat. And in Brazil, it is a sugar cane. And in United States, it is soybean and corn. Means in different countries, they are growing different type of crops for the biofuel production. And overall, biofuels are combustible fuels produced from the biomass. Means they are completely combustible. Okay. Next, this is very important for example. You should make a note it. Okay. See, which are the counterparts to the traditional fossil fuels? Traditionally, we are using the what this is diesel, methane, butane, and ethane. But what are the alternates as a biofuel? It is ethanol, biodiesel, methanol, and bioethanol respective to each other. Okay, make a note of it. Next, biomass, as I told, it is energy stored in the non-fossil organic matter. That is simply means in organic matter which is stored. We are using vegetable oil, straw, waste from the forest, agricultural waste as a source of biomass energy. And if you look into its conversion efficiency, if you take sugarcane, 2% energy is available for 1%, and most food plants it's less than 0.8, and typical forest 0.8, and the maximum theoretical efficiency is given, means overall average it is 10%. And now when the biomass is converted into the energy, some chemical process will be taking place. First it is a biochemical process and thermochemical process. If thermochemical process is occurring, both processes will not occur at a time. Okay, in some case it will be thermochemical and somewhere it will be the biochemical. If thermochemical is occurring, high temperature will be there, higher rate, gasification, pyrolysis, catalytic cracking, plasma, this will be occurring. If it is a biochemical, lower temperature, lower rate, and anaerobic digestion will be taking place. There is biogas production, you can consider biochemical process, and hydrolysis, and ethanol production if it is an aerobic digestion. Okay, make a note of it. Okay, as I told, in the biomass conversion, combustion, gasification, pyrolysis will occur. Combustion, here it is a complete oxygen, means complete in presence of complete oxygen this is taking place. So hot gas, and directly it is related, releasing the steam, heat is generated. Whereas in gasification, here O2 is present but it is limited. Again you will see some reactions in the next slide, yet limited O2 will be there, and it will be generating the low energy gas as well as medium energy gas. And pyrolysis, here no O2, means in complete absence, means it is generating the hydrocarbon and tar. This is what you should remember. See here, syn liquids from the gasification process is generated, syngas, okay, and methane is generated from the gasification. This is what you should remember here. It is the syn liquids generated from the gasification. Next, this is what I so far explained, but from exam point of view, what are the principal products obtained and what are the components obtained from this combustion, gasification, pyrolysis respectively, you should remember. Here, higher amount of oxygen is used here, okay, high, but here it is limited, here absent. The temperature range is mentioned. Please keep a note, that's it, how much high temperature or low temperature, that's it. Here only heat is generated, and as a subproduct it is CO2 and water. They are heat along with some other combustible gases, that is carbon monoxide and H2. And here heat, combustible liquid and combustible gas, everything is generated, CO2. Here only it is char is generated, that is along with the hydrocarbon. This is HC, hydrocarbon and char is generated in pyrolysis. Here absence of oxygen completely. Next, we are at the last part of this particular session. We'll be ending with this solar energy. Okay, solar energy is nothing but it's one of the major source of energy and is also responsible for all other source of energy available on the earth. Means other energy may be there, but for its existence our solar energy is important. Because if I take example of bioenergy, see, if you feel that a biomass energy is also a form of energy, if this biomass has to be accumulated, solar energy is important, right? Solar energy is important. That is why they have mentioned solar energy is responsible for all sources of energy. Please make a note of this statement. Okay. Next, solar energy is, it is inexhaustible and it can be the form of heat and light as well. Okay, it is used for heat as well as for electricity, and this is also most promising unconventional energy. Means conventionally we are not using, means commonly it is not a traditional energy, it is untraditional energy, and moreover it is a renewable energy. Okay. Next, when we looking to its utilization, in two ways you can use the solar energy, that is direct method and the indirect method. Usually the thermal means directly for drying and all you can use. Photovoltaic means photovoltaic cells, okay, solar cells, you can go that way. And indirect method, you can use its wave energy happening due to the influence of solar radiations on the oceans, and biomass generated due to the photosynthesis using the solar radiations. Wind also movement happens due to radiation, and water power. Okay, you should remember these are the indirect methods. Next, talking about the instruments for measuring various things about the related to sun radiations. See, in order to measure the total radiation, we are using the instrument called pyranometer. In order to measure the beam radiation, we are using the instrument called pyrheliometer. Okay, this is what we have looked at to measure pyranometer for beam radiation, pyranometer for total radiation. Okay, don't get confused. Here it is reversed on. Sorry. Okay, using the pyranometer, we are measuring the total radiation, and pyrometer it is beam radiation. Looking into advantage and disadvantages, there is nothing much to explain, but yet I will mention few points. See, though the solar energy is a renewable, pollution free, and it may reducing our electricity bill, and there may not be need of any much maintenance cost. Yet there is some disadvantages that it needs a lot of space, and it is temper season dependent, because in winter season we will not get sufficient amount of solar energy, and implementation is a little bit difficult. That is, the establishment of solar panels may request large of finance and less solar energy in the winter, obviously, yes. And the equipment that we are using to store this energy, that battery will be costly. Okay, next, heat energy transferation takes place in three ways: conduction, convection, radiation. Conduction is simple, it is transferred directly. You can look into the image. Convection, here when you heat this pan, through this water will be heated, right? Energy is transferred by the mass motion of molecules. Radiation transferred by the electromagnetic radiation. Okay, and application: solar cooker and the solar water heater. The dimension of the solar cooker, try to remember if they ask the traditional one. And what is used? See, there is no loss of the vitamins in the food, no pollution, and healthy. And these are the collectors, that is flat plate collector and the evacuator tube collector, that are using for heating waters. And solar still, it is an solar distillation unit, and the principal usage is evaporation and condensation is important. What happens is, here we will be storing some amount of water. This, when the solar radiation enters, it will be a transparent cover of white. When the radiation comes, they will get evaporated, like heated and get evaporated, and once after the evaporation they get condensed and they collect in this condensed channel, which now what this water is condensed, right? This will be our distilled water. This is the simple mechanism. Okay, next, solar pond. Solar pond is nothing but it is a simple device for collecting and selecting the solar heat. Okay, here solar pond combines the solar energy collection as well as sensible heat storage. And these solar ponds are also called solar salt ponds. Why? Because salt is being used, or it is constructed in the brackish water area which is rich in salt. Okay, natural ponds, if you observe there, the convection and the evaporation are more, and the quick loss to the convection process is more, that is, heat will be lost easily. But whereas in the solar pond, we are designing solar pond in such a way that we are reducing the convection as well as evaporating heat loss. See, what we do in solar pond is a great salt concentration at the bottom, then at the top causes the bottom water to have greater density and remains at the bottom and is also hotter. This is why the water, that bottom water remains bottom, top water remains top. That is why solar energy is being absorbed in the deep layers and usually dry. Okay, hope you clear. Next, the application of solar ponds. There are various. I have mentioned few: power generation, agriculture, crop drying, desalination, industrial process heat, and production of renewable liquid fuels, etc. Few applications. And limitation: it requires sunny climate. Obviously, in summer season, it is good. Availability of brackish water, that is salt water, and need for large land area. Okay. See, this is a diagram. Actually, hot water out, cool water in. There will be some lining. Here is saturated salt water. This will be creating some density and making water remain in the lower surface and trap the heat. And they will not be moved from the surface. And last, I want to introduce you people to our mock test bundle, that AgriAddict is giving always a quality content to the students. Again, we are back with this particular mock test bundle. It will be including standard 50 plus standard mock test and previous questions also included, and one-to-one doubt clearing session from the experts will be done. And again, one more important thing is the lecture series, whatever you're watching in the YouTube, the PPTs are also available in that particular mock test, so that you can make use of this and you can boost your preparation. And I wish you all the best for your IBPS AFO mains exam. Wish you become an agriculture field officer. Thank you.